Hi, I'm David Partika, and I created CSS Burner as a rapid optimization tool for CSS. Today, I'm going to show you how to use the statistical analysis function, which is on top here with the bar graph, to look specifically at attribute selectors for a specific style sheet, and maybe we'll do a second one too, and just see what kind of information we can glean from looking at the distribution of attributes that were used in selectors. So attribute selectors is already picked, and let's analyze. Now, I don't think you're going to be able to see the file menu, so I'm picking a file right now, and now it's being scanned. Okay, and we see a distribution here which ranges from a low of 1 occurrence for the hidden attribute was used in a selector to 66 occurrences of the type attribute, which is associated most commonly with the input element, and second place being the for attribute, which is used in labels. So the label element, 58 occurrences. Now, type is a very common attribute used in selectors a lot of times because there are so many different types of input elements that we can use. We can use, for example, type equals text, type equals email, type equals URL, type equals search, type equals radio, checkbox, range, date time. There's a whole slew of these type attributes for input. So it's pretty common to see that. Surprisingly, data attributes, there's only 5. A lot of times, authors use data attributes very extensively in styling in attribute selectors. So what this distribution is telling me is that for this particular style sheet, input elements are very important. So there's probably a lot of form inputs, and there are styles associated with them. And so since label, so the for attribute is also very common, suggests to me that there are labels that are associated with these input elements, and the label elements are being used as part of the styling as well, because the for is almost as common as type. So for some other style sheets, we'll see different attributes as most common. But here again, this is what the graph can tell the authors of the style sheet. It could tell these authors things that they know are particular to what they wrote. And so they can immediately see the numbers and the graph, and they could say, oh yeah, that makes sense, for whatever reason that they know about because they wrote it. And so what I'm seeing simply is input and label elements are important anchors, so to speak, as attribute selectors for their styling, and they would know more. Now the authors at this point can delve more into their code and think about, if there's any changes that they can make. So let's do another one. I'm going to pick again attribute selectors, and I'm going to pick a different style sheet, which I don't believe you can see when I'm selecting. Let's get a big one here. Let's try this one. Okay, so now it's scanning. Okay. And so you see how for different style sheets, what the authors of the style sheet deem as important could change dramatically. It depends on how the style sheet was written. Again, the authors know this. They know this information because they wrote the code. So here we see again data attributes. There's 7 occurrences. Type 47. So type is usually one of the top contenders, if not the most frequent attribute used. Here, in stark contrast to the previous style sheet, 222 occurrences of the class attribute. And what this is probably telling me is that how the authors wrote this style sheet is not only are they just doing, most likely what they're doing is they're not just using, class equals X. they're using the other variations of attribute selectors. So they're using things like, class begins with X, or class ends with X, or class contains X. And that, again, will be known to the author, and it is just specific to this particular application, and they would know. So here, again, we see it seems like input elements are not as important here. They have some importance because input is, the type attribute is present, but clearly the authors are anchoring their styles with respect to attributes. They're anchoring them around the class attribute, and therefore any changes to the DOM which involve class changes would be something that the developers of this project would need to think about if they can do that, because clearly there's a high dependence in this style sheet, the styles, on the class attribute. So if you start randomly deleting classes because, oh, we don't need this class anymore, or this class, maybe we'll think about changing its name, that is going to be something for this style sheet that you really the authors need to think about. So this is the kind of information that developers can glean from the use of the statistical analysis counting strategies, in this case for the attribute selector. So I hope you found this helpful, and if you did, please give this video a thumbs up. And if you haven't subscribed to the optimized CSS channel already, please do so, and look for some more videos in the not so distant future.